in the future and then say evaluate. Okay, so you see the value of having this? It's basically getting the program out of the calculator brain and set it back. But we're going to return it as a property list. It's going to be any object. People are going to look at this var, and it's going to be of type any object, and all they can do is get it and then set it back. Okay, so what would that look like? Let's go over here to our calculator. So I've gone much bigger font here. Hopefully everybody's this big enough. Yeah? Okay. All right, so this is a calculator as I last left it. It doesn't have your enhancements to it for the variables. And I'm just going to add a var here, a public var, okay, called program. And it's going to be type any object. But I'm going to put a comment here that says guaranteed to be a property list. So that callers know that this is a property list. So for example, they could put it into NSUser defaults. Or they could write it out to disk. I haven't taught you how to write out to disk, but you can do it. So they could do that with it because they know it's a property list. Okay, so this is going to be a computed property. Okay, so we're going to have a get and a set. And when the get, we're just going to get some sort of property list representation of our internal data structure. And when you set, we're going to take that property list and turn it back into our private representation. So the get, how are we going to represent ourselves as a property list? Because this is really our internal data structure here. It's an array of op. Op is an enum. Clearly, enums are not NS dates or NS strings or NS arrays, so we can't just return this thing, okay, because that's not a property list. So we need to return some sort of property list, and I'm going to return an array of strings. And the string is either going to be the symbol of an op, in which case I'll look it up in known ops, or the string will be a numeric representation of the string, of their operand rather, right? The double turned into a string, which I happen to have a var that does exactly that. Okay, this turns an enum op into a string. And I know how to turn it back because I know how to use a number formatter to turn the string of an operand back into a double, and obviously I know how to look up binary and unary operations in our known ops. Okay? So we could say something along these lines. You know, our get, I'm going to show you a much better get in a second, but one way we could do our get is we could just say, we could make a return value that is going to be an array of string. Okay? In fact, let's just create an empty array of string here. And then we could just go through our ops in our op stack here. And for each op, we could just say return value, append an ops description onto the end of it. And then we could return value. Right? Makes sense. I just turned my internal data structure into a property list because this is a property list. And notice I can return this through any object because arrays are bridged to NS array, which happens to be an object. Okay? But this is an awful lot of code for this. We can actually do this in one line of code. Okay? So if you paid attention in my last lecture, you remember that I told you about this function called map. And I can actually just return my op stack mapped so that each element's description is returned. So I don't need any of this. Okay? So everyone understand this line of code right here? This is just a little closure that gets the opportunity to convert every single thing inside op stack, which is an op, these are ops, into a string. And it takes this string and maps them all and returns a new array. Okay? So when you start getting familiar with Swift and what it can do, you'll start realizing a lot of things that take 5 or 6 lines of code, you can just do them in one. Okay, but it does take some experience. So now let's talk about going the other way. So now we have, someone gives us back our program. We want to load our op stack back up. Well, the first thing we want to make sure is that the thing that they're giving us back is an array of these symbols. Because they could just give me junk, because it's any object, they could set it to anything. So I want to make sure that's what it is. So I'm going to do, I'm going to let op symbols equal new value, right? New value, remember we are in the setter here. So new value is the new value, which is an any object, as an array of string, because that's what it has to be. If this thing that they passed in is not an array of string, I don't know what to do with it. So really here what I want to do is if let as question mark, because they could pass me anything. And so here I'm using the as to make sure this any object they pass me is actually an array of strings. Okay? If it is, now I can convert back. So I'm going to create something called my new op stack, which is just going to be an array of ops. And I'm just going to go for each op symbol in this op symbols. Op symbols is this thing right here. All right, so that's the array. That's the new value, the any object converted into an array of strings. Okay? So for each one, if I can find a known op that matches that symbol, then this must be an op, and so I will just add that op to my stack. Otherwise, I'm going to see if I can turn that string into an operand, and I'm going to do that with if let operand equal ns number formatter. Okay, number from string. I'm going to pass it this op symbol that I got out of that array it gave me. Now I'm going to use optional chaining here and put a question mark and then double value. Okay, remember optional chaining, if you have an expression like this whole expression, and if anything along the way returns nil, then this whole expression will return nil if you put a question mark after that term. So number from string can return nil if this is not a string that can be interpreted as a number. And so by putting a question mark here, it says, okay, if that's nil, then just return nil back to here. Otherwise, keep going and send it double value. So this operand is either going to not get set because of the if let, or it's going to be a double, which is what this double value comes out of here. Okay, so that's kind of explaining from last week how we did this number formatter thing. So in this case, I can just append onto the end of it that a new op, so we'll say dot operand with that operand. So we're just putting a new op on there. So now I've built a new op stack using all those strings, and I can just return that new op stack. Not return it, sorry. I'm going to set my op stack equal to that new op stack. Okay? That's it. Any questions about that? Yeah.
So why do you say guaranteed to be a property list? Like that's just because
this is documented. This is a public thing. It's not private, and I'm just documenting to anyone who's using it that this is true. I could document this even better using a type alias. So you can basically have a type alias, which is an alias for a type. It's just a way of another type. And I could have a type alias called property list, which just equals any object. Then I could have this type be property list. Okay? So I just created property list as an alias for any object. So someone looking at this is going to go, whoa, what the heck is property list? And then they're going to look at this type alias and say, oh, that's any object. But they're really going to understand that I'm returning a property list here. And the reason it's property list, again, so I can throw it in its user defaults or whatever. Okay? But otherwise, it's only good, the only thing it's good for is giving it back to me to reset my program in the future. That's all this thing is good for. Now, you're going to want to add this to your assignment for assignment 3. Okay? So, all right, back to slides. I don't have time to really run this, unfortunately, due to test code because we are schedule constrained here. So let's go back to here. Continue. All right, so now let's talk about new thing here, which is views. Okay, totally new topic. A view, that is to say, a subclass of the class UI view in iOS, represents a rectangular area on the screen that defines a coordinate space to draw in and also to handle touch events. Okay, that's what a view is. And you are going to learn today how to make your own views. The views are hierarchical, so views are within views are within views. Any view only has one super view, right? It's only contained directly in one view, but it can have any number of subviews. So in our calculator, we had a top-level view, which I'm going to talk about in a moment, and then we had a lot of subviews. All the buttons, the labels, those are all UI view subclasses. Okay? And so we made a whole bunch of subviews in that view. But we can go even deeper. It's hierarchical, multi-layer. We can go as deep as we want. You can see the two properties there for getting your super view. Notice it returns a optional. That's because you can have a view that's not currently on screen. It's not currently in a view hierarchy, of course, so that could be nil. Your subviews, I show array of UI view there. Actually, the subviews property is an array of any object, again for historical reasons, but there will always be UI views in there. So don't even worry about that. Okay? And usually in this class on the slides, if something's an array of any object, if there's going to be a certain kind of thing in there, I'll say array of the certain kind of thing. But when you write your code, then obviously you might see, oh, that's array of any object. And that's, again, the bridging will work here automatically, so there's no worries there. UI window, there is a thing called a UI window. It's a subclass UI view, but it has no meaning really in iOS. There is a UI window. It's at the very, very, very top of each device screen, but you never send it any messages really. You don't interact with it. It's all about views. Okay? On a desktop, windows matter, but on iOS, it's all about views. Okay? So don't worry about UI window. This hierarchy of views, subviews and superviews, is created usually graphically. You drag things out in your storyboard, and you can drag views inside other views to create your hierarchy. But you can do it in code as well. It's pretty rare to do it in code, but you can. There's two methods here, add subview and remove from superview. Add subview is sent to the prospective superview, in other words, to the place you want to add this view into. And remove from superview is sent to the view that you want to remove. So these are sent to different people, okay? Remove from superview means remove yourself from your superview. All right, so where does the view hierarchy start? Where's kind of the root, the top level of this view hierarchy? And the answer is very simple, but for some reason students have a very difficult time understanding this one. There is a property in your UI view controller called view, and it is the top level view in the scene in the storyboard. Right? So you have this storyboard, you've got your scene that we've seen, like your calculator one. The top level one, the place where you're going to add your top level views, is called view in your view controller. It's just a property in your view controller. So it really couldn't be simpler. Okay? But sometimes students, they just forget that that's there, and they're like, oh, how do I add something to my storyboard, you know, in code or something like that? Well, you just add it to the view of your UI view controller. Okay? So let's talk about initializing a view. As usual, as I've kind of recommended, you probably want to avoid doing an initializer if you can. So initialize any properties in your view, hopefully using equals or some of the other ways we talked about doing it. But in UI view, it's actually slightly more likely that you might want to have an initializer. So it's a slightly complicated thing, only slightly, in that UI view has two initializers that you have to deal with. And that's because UI views can be created in two different ways. In code, by just saying UI view and this frame initializer, which is just the frame in the super view coordinate system where this view is going to live. But then there's also this init with coder, and I'm not going to talk about coders and archiving and all that, but that is the initializer that is called when the view comes out of a storyboard. So if you create a view by dragging out in a storyboard, its initializer is this coder thing, okay? So if you absolutely have to use an initializer to initialize something in your UI view, you're going to want to implement both of these things. And I recommend this kind of format here, where you override init with frame there. That is a designated initializer in UI view. And then there's actually a required initializer, which is the decoder one. So if you implement the init with frame, you have to implement the coder ones required. Because then as soon as you implement the init with frame, you'll no longer inherit all of your designated initializers. You won't inherit the init with the coder. So basically implement them both and then just factor out your initialization code into some setup method or something and call that. Okay? So that's only if you absolutely have to have an initializer. All right, there's another alternative to initializing, which is if you can wait until the initialization is finished, but you want something really early in the view's life, you can implement this method awake from nib. But that only works for views that come out of a storyboard. Okay? Awake from nib means I just awoke from coming out of a storyboard, so now you can initialize me. So it's a little bit limited because it only is good for views that come out of a storyboard, but it is an alternative. Now, okay, so that's all I want to say about that, actually. All right, so let's go on to how do we draw and handle events in this rectangular area. Well, we need a coordinate system to work in. So there's some data structures I'm going to show you real quick to get us started here that we're going to use when we're drawing and handling events. First of all coordinates are going to be CG floats. Okay, CG floats is a type in Swift struct, and always use CG float when you're drawing or handling events in a view. Do not use double, do not use float. If you use those in your homework, you're going to get dinged, okay? CG float. Now, doubles and floats can be converted to a CG float using the initializer. CG float has initializers for floats and doubles that you can pass and turn it into a float. But you always want things to be CG floats when you're working in the coordinate system, okay? Now, there's a couple other structs that are important here. One is CG point. It's just two floats, x and y. It just defines a point in the coordinate system. Couldn't be simpler, okay? And there's also CG size. Just defines a width and a height in the coordinate system, okay? So these are just simple structs. That's all they are, structs. I don't know, certainly point I don't think has any other methods on it or anything. Size, maybe, I don't think so though. But these two are combined, the points and the size, to CG rect. So a CG rect is a struct that has a point and a size. The point is the origin of the rect, upper left, which I'm going to talk about in a second. And then the size is the width and height. Now rect has a lot of methods on it. Okay, rect has things like min x, which is the left edge of the rect, or mid y, which is the midpoint of the rectangle vertically, or intersects, and you pass it another rect, and it'll tell you Boolean whether it intersects that rect, right? The two rects overlap. Or intersect, which says take this other rect and create a smaller rectangle, which is the intersection of those two rects. Or contains point, okay? Where you pass it a point, and it'll tell you whether it contains that point. So rect, it's a struct, but it has a lot of cool methods in there. There's a whole bunch more. You can just type a rect type and then a dot, and let Xcode show you all the cool methods it has, okay? All right, so those are the kind of data types we're going to use to talk about our coordinate system and to write our code in our coordinate system. So let's talk about the view's coordinate system itself. First of all, origin upper left. Some of you might be used to origin lower left, like Cartesian coordinates, the origin is in the lower left. But all the origin that you use in a view is in the upper left. So that means increasing y is down the screen. Increasing x is across. So I put an example 500, 500,35 over there. It's 500 across and only 35 down, okay, from the upper left. The units that we're talking about here are points, not pixels, okay? Very high resolution displays have more than one pixel per point, okay? Because they're able to draw very fine curves, very fine text, etc. You don't usually care about the difference between points and pixels. It's automatically handled for you because you're doing things like drawing text or drawing an arc, and the system automatically uses as much pixels as it can to make things nice. But occasionally you do care because maybe you're drawing something very finely detailed and you want to control on pixel boundaries. And if you want to do that, you can get this property in view called content scale factor, and it will return the number of pixels per point. So on a retina display, that's going to be 2. On a non-retina display, that will be 1. It could be anything though, okay? So you shouldn't write your code assuming it's 2 or 1. You should just write your code, get the content scale factor, and you'll know how many pixels per point. Okay? 99% of the time you don't have to worry about this, but in your assignment 3, hint, hint, you might have to. Okay? So what about the boundaries of where drawing happens? You've got this rectangular area. Well, there's a very important property called bounds, which is a CG rect, which describes the area you're drawing in your own coordinate system. Okay? It's important that it's in your own coordinate system because these views can be scaled and even rotated and translated to other coordinate systems, but when you're using the bounds and you're drawing yourself, you have this rectangle, you know where it is. Now, the origin of your bounds usually is 0, 0, but you could define it to mean something else. For example, scroll views, they define their origin to be where they are in the thing they're scrolling. That's just what they define origin to be. But 90% of the time, your origin is just going to be 0, 0. And so the width and height is what you're going to care about. How big a space am I drawing into? There are two other properties that often get confused with bounds, but don't let this happen to you. One is center. Center is the center of your view rectangle in your super view's coordinate system, not in yours. So if you write code that says, oh, I want to start draw something in the middle of my rectangle, I'll get center. That's wrong, okay? Center is in your super views. Center positions you. It has nothing to do with how you draw. It just says where you are in your super view. Same thing, frame. Frame is a rectangle in your super view's coordinate system that contains you. Okay, it contains all of you, of your drawing. But it's in your super view's coordinate system, so it's only good to position you, not for drawing. When you're drawing, you use bounds. To kind of give you a picture of this, it's better. Like you might think that the frame size is exactly the same as the bound size, right? If it's a rectangle that contains my rectangle, it must be exactly the same size. But no, because views can be rotated, okay? And if you rotate your view like this green view, look how much bigger the frame is. The rectangle that contains you is much bigger than you because you're tilted, right? Make sense? So don't confuse frame and center, which are about positioning, with bounds, which is your size, the area that you're drawing into in your own coordinate system. Okay? Okay, so creating views. How do we create views? Most often, views are created by dragging them out into your storyboard. Okay? That's 95% of the time. But of course, your views aren't sitting in the object palette. There's buttons and sliders, but there's no your view. So you have to drag out a generic view. It's kind of at the bottom of the palette. You just drag it out. Once you drag it out, though, you have to go to the identity inspector and change the class of that view you dragged out so that it's your class. Okay? So it's a two-step process. You drag your custom view out, then you change this class to be whatever your custom class is. On rare occasion, you might create an instance of your view in code. Probably never in this class, maybe in your final project, although I doubt it. You just do that using UI views frame initializer, right? So you just say view equals UI view frame. You can even do UI view with no arguments. It'll give you a CG rect 0, which is a frame 0 size and width, and then you could later set its frame to position the view. So here's an example of creating a view in code. I'm going to use UI label. A UI label is a subclass of UI view, so I can send it UI label parentheses frame. So I just give it this frame, which is kind of in the upper left. Notice I've created this view, but it's not on screen yet. Okay? Assuming this code here is in a view controller, I could then say view.addSubview, because remember, view is a property in my view controller, which is that top level view. And I can say add subview of the label, and boom, it'll appear on screen. Okay, at 2020, width 100, height 50. Okay? So it is possible to create views in code. We almost never do that in iOS. We use storyboards. Okay, so when do I want to create my own UI view, right? Well, when don't you want to? Well, you don't want to if you want a button or a slider or anything where there's already an iOS view. But if you want to do something that those things can't do, draw something special or handle touch events like swipes and taps and pinches differently or for a different purpose than those things, then you create your own custom view. So we're going to focus on drawing today, and I'll do gestures in the next beginning of the next lecture. To draw in your UI view, all you need to do is override this method drawRect. Okay? Very simple method, only takes one argument. In the code, it's actually called rect, but I've renamed it to be region that needs to be drawn so that people understand what that argument is. That argument is purely an optimization. It's just the system saying, hey, draw yourself, and really I only care about this rectangle of you. But you can draw the whole self if you want, but this is the only rectangle I really care about. So if you had a view that knew how to draw parts of itself, okay, then it could only draw the part that's in this rectangle. But you can completely ignore this rectangle if you want. It's purely an optimization. Okay? This is very important to understand. You never call drawRect. Ever, never. never, okay? If you call DrawRect in your homework, you're going to be major ding, because I'm standing here in front of you with red text on my slide saying never, okay? Do not call DrawRect. DrawRect is called by the system, okay? It's called by the system when your view needs to be redrawn. How does the system know your view needs to be redrawn? Because somebody called setNeedsDisplay on your view. And you can call it on yourself if you want. If something has changed about your view, some property or something that would change the way it's drawn, you call setNeedsDisplay on yourself. Eventually, the system will call your DrawRect. But it's got to set some things up first, okay? And there's other views around you that it has to get organized, okay? So never call DrawRect, it's called for you. When you call setNeedsDisplay, you can specify, I really only need this rectangle redisplayed. And then obviously that rectangle is going to show up in the argument to DrawRect. Okay? But if multiple people call setNeedsDisplay with different rectangles, probably the union of those rectangles might get called here one time for DrawRect. Okay? Make sense? All right. So how do you implement this all-powerful DrawRect method? You can use kind of a C-like function-based API called Core Graphics. That's what it's all based on. Or you can use a nice object-oriented thing called UI Bezier Path, which is what we're going to use because we like object-oriented. But since the underlying stuff, Core Graphics, is what UI Bezier Path is built on, I'm going to kind of explain a little bit about the concepts of Core Graphics, how one draws in Core Graphics. The first thing in Core Graphics that's important is you have to get a context to draw in. Okay? So if you're printing, you'll have a printing context. If you're drawing on screen, you'll have a draw on screen context, etc. And inside DrawRect, when your DrawRect is called by the system, it sets up the drawing context for you. So it's automatically set up, and it's called the current context, the current drawing context. And you can get it if you were using the C API, or C-like API, it's still Swift, but it's functional, function API. You can get it with this function UI graphics get current context, and it'll return this cookie. It's just this magic cookie. You don't know what it is, but it is the context of drawing. Because all of the C-like functional API take a context as an argument. Okay? The Bezier path doesn't do that, no worries, but that one does. So the first thing you need is a context, automatically set up for you when DrawRect is called. Then you create paths. You create paths with lines and arcs and things like that. Then you set the drawing attributes, like the colors you want to draw in, the line widths, things like that. And finally, you stroke and fill those paths. Okay? You can do either or both, stroking and filling. So that is fundamentally how you draw. Things like drawing text is just the fonts know how to have the perfect path to draw beautiful letters. And so your stroking would outline the letters, and filling fills in the letters, okay? So even drawing text is just stroking and filling paths, okay? Now UI Bezier path, this object-oriented thing on top, it always draws in the current context. You don't have to worry about context. It has methods to do things like line 2, arc 2 to build the path. It also has methods for setting a lot of these attributes like line width and things like that. And it has methods to stroke and fill. So it combines all those core graphics things into one class. So let's take a look at UI Bezier path and how we would use it to draw a triangle, let's say. So first we create the path, so we just say UI Bezier path. There are other initializers for UI Bezier path, but you can also just create an empty path, and then you can start moving around. So here I'm going to assume this screen is 160 points wide by 250 wide, and I'm going to draw this triangle here. So I'm going to move to 80, which is halfway across, and 50, which is a little bit down. And then I'm going to add a line down to 140, 150. Then I'm going to add another line over to 10, 150. Then I'm going to close this path. Okay? So that's it. That's how you can make a triangle. Now, I'm kind of lying to you a little bit because as you execute these, nothing is appearing on screen. The screen will be blank. Okay? I was only showing them so you can understand what I was doing there with the lines. So it'll be blank. To make it appear, you have to stroke or fill. So let's set the attributes we want. So I'm going to set the color for filling to be green and the color for stroking to be red. Okay, now notice that I set those with methods on UI color, not with methods on the Bezier path. Okay, that's a little interesting, but that's the way that works. But line width, I do set by talking to the path. So I said in a message to the Bezier path, set line with the 3. So once I've set up all my attributes, now I can fill, for example, by saying path fill, and see, I get the rectangle filled in green. Or I can say stroke, and it'll stroke the red.